let's say 2G architecture of GSM. So we'll look into the protocols and the interfaces between the different network elements. So let's start with the MSC, which is the brain of NSS, network subsystem. So let me draw an MSC here. MSC. Let me connect that with another MSC. Then this goes to an ISDN network. Now MSC, as we all know, is connected to the BSC, base subsystem controller, then which is connected to the BTS, base transceiver subsystem. The functions of all these small boxes I'll be covering in a little bit of detail, just not that much of a detail, but just a little bit. And it's responsible for call control. It's responsible for location updating. It controls the BSC. It's responsible for allocating radio resources and so on and so forth. Well, let's look at the BSC now. Base station controller is responsible for handovers. Even MSC is responsible for inter-MSC, inter-BSC handover. Base station controller is responsible for relaying the information that MSC wants to convey to BTS, and also it's responsible for measurements of different control reports that BTS sends to the BSC, handovers, radio resource allocation links, and stuff like that. BTS, on the other hand, is responsible for paging the mobile, coding. It has a transceiver which is responsible for receiving and and transmitting the radio link. It's a radio link between the mobile and the base station, base transceiver subsystem. All right, so let's do that. And here is the EIR equipment. Interface register. Here is the HLR, home location register, which records the mobile's data, the subscriber data. It has the MC, the MSISDN. Temporarily, it has the MSRN. And let's look at the VLR, visitor location register, which has the MC, TIMC. We'll cover these terms in more details in some other video. VLR, which is a visitor location register, and then here's another VLR. Okay, so let's not. Here's another VLR. We look into. So these two are connected. Let's look at the interface. interface is the interface between mobile subsystem and the BTS, and the protocol between them is LAPD with M, which means it is specifically modified for GSM. The interface here between BTS and BSC is the A-BIS interface, and again the protocol is LAPD. The interface here is the A interface. Protocol is BSS MAP, mobile application based subsystem, mobile application part. The interface with MSC and MSC is the E interface. MAP is the mobile application part of the interface, is a protocol which is uh, a non-call related protocol for conversation in between the NSS network elements. So for example, here the interface is C interface. It's a D interface here, B, F, and we have G interface between a VLR and a VLR. HLR and a VLR is a D interface. All these interfaces are well, you will find more details on the GPP technical specifications more if you want to know more about these interfaces. The interface between MSC and the ISDN is the ISUP, or telephone user port. What else do we have? These interfaces F, C, B, and D and G interfaces are basically the communication over these interfaces is the MAP protocol. Let's also talk a little bit about LAP DM protocol and the messages that goes in between, that goes in the information field. There are three types of messages that LAPDM protocol's information field will carry. One is the RIL3 RR message, which is radio resource message, which is responsible for the radio channel requests, power control measurements. And the second type of message is the RIL-MM message, which is just mobile management, which is responsible for ciphering, authentication, location update. The third type of message is the CM message, which is responsible for call management, setup, alerting, and disconnect. So these are the three type of messages that you will be able to see going back and forth in the information field of the LAPDM protocol structure. That's it for today. We'll see more in the next video.